Welcome back, everyone. Today we're continuing our series on Lambda. We are talking now about integrating Lambda with SQS. So previous videos we had requests coming in, just hitting our Lambda directly, HTTP requests. We built out our REST API. We integrated that with RDS as well, so that we could actually write data and store that into DBs. So now we're going to have external requests coming into the Lambda via SQS, and SQS will be triggering our Lambda. So we'll have events coming in. They will be stored in the queue, and that queue will send over events to Lambda for processing. So I have kind of mapped out here a couple of Lambdas showing just a couple of different things. So Lambdas will scale just for free out of the box to handle whatever volume or load is coming out of the SQS. That's why you can kind of see three of them there. So SQS is a really, I would say, basic foundational block of any kind of cloud architecture, and it's super important to understand here. So the idea, we'll kind of walk through this in depth here, but the idea is the event will come in, be sent over to your Lambda, basically trigger your Lambda. Your Lambda will attempt to process it, and if that fails, if processing fails, it will go back to the SQS to be retried. So there's kind of some built-in redundancy there. So just in case, things do break sometimes, things do fail sometimes, but just in case, when events come in, if they fail to be processed, we get retries out of the box. And that'll happen until the event has been tried, basically the maximum retry count. So you can see there, this is something we set. It is just an arbitrary number that you set. You could have 2 times, so you'll attempt to process an event once, twice, 3 times, whatever you set. And once it fails to process, once it reaches that max retry count, it'll be dropped down into a dead letter queue. So that dead letter queue essentially stores failed messages. So this would be a place that you could track and see, are there errors, are there things going wrong in my system? Typically, you don't want messages ending up in your dead letter queue. If they do, you should debug and investigate that. So once Lambda has successfully received a message, processed it, and emitted that out, done whatever it needs to, basically what'll happen is Lambda will notify SQS, hey, this event is good, and it'll be removed from the queue. It won't get retried anymore. Now, moving on towards the bottom here, let's talk a little bit about why we need SQS. Just I guess a couple of simple use cases for you to get an understanding on. If you don't know, I would really recommend heavily investing time in understanding SQS. In any kind of cloud-based system, you're going to be using queues and this kind of asynchronous messaging very frequently, whether it's SQS or SNS. We'll cover that later. It's another Amazon service. But you'll use these message processing systems very frequently. This is kind of the foundations. So the first one on top there is the user sign up. So let's say we have some front-end login form. Users enter a username, password, click submit. So when they do that, there's a couple of things we want to happen. Maybe we want to send out a welcome email. And also maybe we want to start some user processing. So we have some behind the scenes things that need to happen that might take a little bit more time. So the welcome email, for example, that probably isn't going to be instantaneous, right? When the user clicks that login button, our backend would have to probably reach out to some third-party service, I don't know, say MailChimp, for example, to fire off a welcome email to that user. What happens if MailChimp is down? What happens if we get a 500? Do we stop the whole sign-up process? Do we give the user a 500 right there? What happens if MailChimp takes a long time to respond? Do we just sit there and hang on that sign-up button for 15-20 seconds? What do we do? So that's kind of where the magic of this whole asynchronous processing idea comes. We can use SQS. So when the user signs up, we can just do a quick write to maybe a DB to store the user's information, or we can just submit all of that information entirely into SQS for asynchronous processing. So once we get that event into the queue, basically we could trigger a Lambda to go emit an email. So go to MailChimp or go to SES, which is Amazon's email service, So we could fire off that email, and however long it takes to send, that's okay. However many times we need to retry that process, that's okay too. And then when the email is sent, that message is processed and is removed from the queue. Similarly, any other user processing we need to do, it can just be done from a queue, so that sign up flow is very quick. The user clicks a button, a message is emitted, and then that's it. We give them a 200 back and they continue on with the flow. So that's one use of it. Second use of it would be any kind of entity modification. So oftentimes you'll have like kind of a central kind of controlling DB that stores like all of your actual data. But then you'll have some caches, or you'll have some other services that store portions of your data. So maybe some sorted portions of your data, maybe some cleaned or modified portions of your data. Like for example, Elasticsearch. Typically you'll have a database, RDS, or I don't know, Mongo or NoSQL, whatever, DynamoDB. You'll have some kind of database that actually stores data, but typically you don't want to be sending high volumes of traffic to that database doing a ton of searches or complicated queries. Usually what you'll see, people will use a third-party service like Elasticsearch or something else to index that data. So you store subsets of the data, portions of the data that have been sorted, cleaned, arranged in better ways. So Elasticsearch, things like that are built to have high volume traffic, whereas like RDS isn't. So anytime you're doing an entity modification, you create something, you update something, etc. One, you want to store it in your central database that has kind of the cold or slow storage. But then two, you would probably want to emit an event and get that updated in your search index or whatever other system you might have. So in that case, when the user maybe updates their profile, an event would get sent off to a queue, and some service, a Lambda or some other service, would process that event to update your search indexes or to update other third-party systems. There's another example. So any kind of entity modification, typically there's a lot of process that happens anytime that happens. So queues are great for that. You can kind of fan it out and send it to multiple consumers. So another thing, user buys a product. So this is just a high-level business example, I guess. There's many different processes you want to start here. I've outlined 3 of them. So one of them would be like start shipping. So when the user buys a product, again, when they click buy, right? Amazon has that buy now, right? One-click buy. Which is just you click it and it just shipped and done right there. When you click that, they don't want you to hang there for 30 seconds or a minute while all of these processes kick off, right? While they notify their warehouse, hey, we need to ship this product with this SKU, with this SKU, this identifier to this user with this address. We need to get some postage, some stamps, etc. They don't want to do that. They want the user to click that button and continue shopping, right? So speed there really matters. So probably what they're doing, or what they could do, is emit an event, right? Send something off to SQS, so that different consumers, one consumer could start the shipping process. Another consumer could take that event and send an email like, hey, yes, we got your order, it shipped, here's the receipt. And then a third consumer would take that event and process and update their storage, right? So we sold this product. We need to reduce the product count by 1 for this product. So that's kind of the idea behind SQS. And actions and systems trigger many other actions, right? They like a single action in a modern system or a modern app will have many actions, and you don't want to hang and wait for all of those actions to complete before the user gets their immediate feedback. So that's where these kind of asynchronous messaging systems like SQS or SNS or Kinesis, etc., that's where they come and play, and they're really foundational to these kind of asynchronous distributed cloud-based architectures. So SQS, foundational block, super important, super basic, and good to understand. So with all that being said, let's go ahead and start in. So one thing I want to touch on briefly is kind of exactly what these events look like. So an SQS sends it to a Lambda. What is that going to look like in code, right? Is it going to be some JSON object? What is it going to look like? So right here, I'm just on Amazon's docs for Lambda and looking at an example for SQS. So here's an example message coming in from SQS, and we see here, basically it's a JSON payload coming in, right? And there's this records object. So the idea behind this is Lambdas read a batch of events. This is another value that we set. So you can set to read 10 events at a time, 2 events at a time, or a single. Basically, these are messages off the queue. How many messages at once we process off the queue? When the Lambda receives those, it receives this kind of object right here, and you see this array of records. Here's an example with multiple events here, so you can see 1 record, 2 record. And then a key thing to keep an eye out here is the body. So this is the actual kind of payload or data that's coming in to the Lambda. So that could be anything. That's anything we choose. It could be a string, it could be a JSON encoded object, whatever. So typically you'll get this array of records, and you'll loop through each of them, and you'll kind of decode that body, and you'll perform your actions on the body from there, whether that's updating a database, updating Elasticsearch, or sending an email, whatever. You'll typically decode that body, and that's sort of the payload of the Lambda here. All right, so starting out, let's provision our SQS. So I'm going to go to the SQS dashboard. You can search or just click in. I'll click Create Queue here. I don't have any other queues ready. And once we're in here, we'll see 2 different options. So we have standard and FIFO. So just one thing, you can't change the queue type, so make sure you know what you're doing. So differences between these two: standard, you can see it says at least once, and messaging ordering isn't preserved. FIFO is first in, first out. Messaging order is preserved. So some differences here. This can be a little bit important. So if you can handle duplicate events being processed multiple times, basically, so an event comes in, maybe you'll end up processing it 3 times. Then you can go ahead and use a standard. Another thing too behind standard is you don't care about event ordering. So there's no promises of order. So events 1, 2, 3 can come in. Maybe you'll process it 2, 3, 1 or 1, 3, 2. There's no guarantee of a consistent ordering. So typically, if you don't know whether or not your system can handle processing events multiple times, duplicate events, or if your system needs actual ordering, like a first in, first out queue, then just go with FIFO. Honestly, typically I just recommend using FIFO unless you have a very strong reason for using standard and you know why you want to use standard. So for this video, we'll just use standard. And feel free to read up and look into documentation more and some differences and probably use cases too. But moving on here, let's go ahead and type in the name here. So when you do FIFO, you need to put .FIFO at the end of the queue name. So we'll do devq.FIFO. And here's some other configuration we can do. We'll just leave defaults here. This is kind of stuff you can do: how long you'll keep your message max size, some delays. If you want to wait before you process the message, that's kind of like receive message wait time, etc. But we'll just keep this default and keep this instantaneous here. And here we're choosing access policy. So we don't have any complex use cases, nothing crazy going on. We'll just stick with defaults here. And then on the bottom here, you can see the dead letter queue. You can enable it. When you enable it here, you need to choose an existing queue. So we'll create this queue initially, and we'll come back and modify it, and we'll add in the dead letter queue. So we need to create a second queue that's going to act as our dead letter queue. So we'll just leave the other options as defaults, and let's go ahead and create the queue. Okay, so we've created our queue. We can copy that ARN. So let's go back, and now we're going to create our dead letter queue. So let's repeat that process. Dev queue, and we'll just put DLQ at the end, .FIFO. Defaults, that's fine, just the same. And here is where we'll set this up. So this is our dead letter queue, so we don't want to set it here. We want to go back and modify our other queue and set this one as the dead letter queue. So let's go back to queues, click dev queue, and we'll edit that. And now we can choose this option here. And we'll select dev queue, DLQ, and maximum receives. We're going to drop this to 3. So this is basically the max retry count. So how many times the message can fail to be processed before it goes to the DLQ. Okay. So we have our 2 queues. We got dev queue and dev queue DLQ. So we're all set up here. Let's start moving on to the Lambda. Let's integrate this with Lambda now. So inside the queue here, under Lambda triggers, we can see any Lambda triggers we've set up. We don't have anything configured, nothing's wired up yet. We'll actually need to create a Lambda first, and then we can configure them to communicate and talk to each other. So let's go over here. So this is dev Lambda, that's from our previous videos. Let's make a new one here. We'll do from scratch, and we're going to choose Go. And we'll leave it as x86. And we don't need to worry about these advanced settings. Let's just create a basic function. Yep, we can just leave all these and we'll just hit create function. And got devq lambda. So now we need to kind of set up a trigger. So one way we can do this is go back to our SQS page. We'll jump into devq. And here we can go ahead and configure that. So we can choose a function. Let's choose the one we just made, devq lambda, and we'll hit save. And so here we get an error message, provided execution role does not have permissions to call receive message on SQS. So we need to edit the permissions of our Lambda to give it that receive message permission. So let's go back to our Lambda here. Under configuration and permissions, we can edit that execution role. So that's what we need to edit here. So let's go ahead and click that. Okay, so now we're over here in IAM and we can modify the permissions. So we're looking for SQS permissions, and I believe it was receive message is what we needed. So we'll just use one of these pre-built ones, and this has what we need: receive, delete, etc. So let's just go ahead and check that. Okay, and we can attach that now. All right, so policy has been attached to the role for our Lambda. So now we should be able to wire this up. We may need to refresh the page here. Let's try. Yeah, so we need to refresh that. Okay, so we'll choose our function again, and let's hit save. Okay, so Lambda function is triggered when a message arrives in this queue. All right, so we're all set up here. So we've got our Lambda, we got the trigger set up. So now let's work on the code for our Lambda just to kind of log out that event. So let's handle the message now. We've worked on the left-hand side, so we set up the SQS and the dead letter queue here. So the queue is going to emit those events. So now we're just on this right-hand side where we're working with the Lambdas. Let's hop into the code and process one of these events. Okay, so we're in the developer guide for Lambda, and we're just looking at a Go example of working with SQS. So we can see here just a simple handler. The main function is calling that handler essentially. There's the payload that we see that Lambda handlers need, and if you remember from that little documentation, that request that had multiple records we looked at earlier, so you can see we're just looping over those records and basically printing them out. And here we've got our super simple Lambda setup. If you watch the previous videos in the series, you'll kind of know what's going on here. We've got our main function calling the handler, just a really basic handler set up, just logging things out. And then we have a init on the top, which is setting up a logger. We're using Uber's Zap logger. It's just really basic, really simple, clean, structured logger that gives us nice logs, kind of formatted in JSON format. Yeah, so that's all we're doing, just looping through the SQS records and logging the event. So let's go ahead and get this all zipped up here. And we'll come back and process the JSON that we're going to get in message.body. We'll do that next. But for now, let's just log out the actual events we're getting. So let's pop up a terminal and we'll just run our generate zip.sh. And if you don't have this, either check the description or watch some of the previous videos where we walk through what it is and why we're doing it. It just builds the executable binary and then zips it up into a folder that we can upload to AWS. All right, so we have our zip file that has our binary now. Let's upload that to AWS. One thing to keep in mind too, the zip that we put out is called main. So we're going to have to change just some basic configuration in the Lambda to look for main. I think it looks for handler as a default. So let's go to runtime settings. And we can click edit, and we'll just change that to main. You can put whatever you called your zip. Okay, and let's upload from zip, and we'll select the file. We'll hit save. All right, so we're all set up here. We should be able to read logs in CloudWatch when this Lambda gets events, but let's go ahead and send a message. So we can go back to SQS and hit send, receive messages here, and this lets you play around and test. So we can put in message body, message group ID, and deduplication ID, and whatever other attributes we want. Those other attributes are optional, but we need to also put in the group ID and the deduplication ID. So when you submit messages to a queue via like an API or some other service, you don't have to worry about these. It's just for this kind of manual send and receive messages that we're doing here. So let's go ahead and input just some test stuff. And eventually, remember, this message body will be a JSON as well, but we're just doing a basic string for now. And we'll just put in just some test numbers here, and we'll send the message. Okay, so that's sent. Our Lambda should be receiving that shortly. If we go back to the queue, you can hit monitoring here. And you may have to wait a little bit for it to show up, but you'll be able to actually see the number of messages coming into your queue, been received, been deleted, so it's been successfully processed, etc. But let's go over to Lambda and let's get our CloudWatch logs, and we should see this event hopefully coming through. So we view logs in CloudWatch, and there's a log stream for us. Let's click that, and there we go. So we see right there. So there's our message, received SQS event, and there's the actual event. So there's message ID, the body, and all those other attributes right there. And yeah, so that's working well here. So the next step, let's go ahead and set this up so that we can receive a JSON in the body here and decode that. So let's go back into our code. We'll get rid of the comment there. And for each message, we're going to get a body, basically. So let's decode that JSON. So we'll set up an event, just a basic event object, and then we're going to unmarshal the message. Into that event, and we'll log out the decoded JSON. And let's also make sure to catch this error. So if it's not nil, we want to return the error too. So in this case, that would push the message to be retried, and then eventually this would go into our dead letter queue. So if that event didn't have a correct formatted body, it would be an error, and it would get retried 3 times. That's what we set it to, and then eventually end up in the dead letter queue. All right, so we zipped it up. Let's go ahead and upload again. Okay, functions updated, and now we can submit another event. So let's submit one event here that should fail. So name has to be a string, but we're giving this a 2. We'll send that. So that should fail and end up in the dead letter queue eventually. Let's see, let's go to logs, and let's find the latest ones. All right, so we see there is an error. So we received it, but here's that error. So we're trying to unmarshal it. We can't, it's failing. So we should be able to refresh this, and it should show back up. So we should see this process 3 times. May take a little bit to show up, but let's just keep refreshing here. So there we see it show up again for the 2nd time. So we've processed twice now. We should be able to process it once more, and then it should successfully end up in our dead letter queue. There we go. So there's the 3rd time processing. So now if we go back to our SQSs and we go to debug DLQ, we should actually see this show up. And if we go to send and receive messages, so you can send messages, but you can also receive them. So you can pull for messages that are currently in the queue. So we start pulling, and right there we see we got one message down at the bottom. Yep, so you can send, and you can see there, we can open up that message and see exactly the details of it. So we see the body there, name 2, so we know, okay, let's go back in and fix how we're parsing. So let's set up an event. We'll say name, anything. We'll put dev topics, and we'll give it another unique group ID and dedupe ID. I've sent a couple other messages through, so those should all be showing up in the logs. There's one of our older ones. Let's refresh. So there we've got the other event with dev topics in the name, and we see that successfully decoded. Dev topics is in the name. So we've got that JSON object that we can work with in the backend. But yeah, okay, so there we go. So that is how we set up and kind of process messages off of an SQS and eventually end up in the dead letter queue. So we've set everything up here, got our basic integration working, and yeah, there's the video. So thanks for watching. Hope you really enjoyed this. Hope you were able to learn something, and make sure to like, comment, and subscribe to the channel. Really helps me out, lets me know to keep making these videos, and yeah, thanks for watching, and I will see you in the next one.